You'll often hear politicians argue whether a cut in your wage tax might not lead to more tax revenue being generated because you'll end up working more. Whether this is true or not depends on the relative size of wealth and substitution effects. But before we can get to that, we'll analyze in this graph how we can read the amount of tax that you actually pay under a wage tax. Then, in graph 8.4, we'll consider in more detail the politicians' arguments. We begin by again assuming that you have 60 hours of leisure available to you per week that you can sell in the labor market. And we'll start with your without tax budget constraint graphed here. If you have to pay a wage tax, that's equivalent to a decrease in your wage, and therefore results in an inward rotation of your budget constraint through your endowment bundle E. We'll talk later on in the text about the process by which wage taxes are split between employers and employees, but for now we'll simply assume that at least part of the wage tax is passed on to the worker and therefore lowers his take-home pay. In order for us to determine how much a worker will actually pay in taxes, we have to know what the worker will do after the tax is imposed. So we have to know the worker's optimal bundle A on the after-tax budget constraint. Suppose here that after the tax is imposed, the worker works for 40 hours a week, therefore consuming 20 hours of leisure, and brings home $800 in a paycheck. Next, we can ask the following hypothetical question. Suppose the worker had worked for 40 hours a week and thus taken 20 hours of leisure before the tax was imposed. How much in other goods consumption would he have been able to engage in? In other words, how much of a paycheck would he have brought home then? We can see the answer by looking at the lowercase a bundle on the magenta budget constraint. At that bundle, the worker works for 40 hours a week, takes 20 hours of leisure, and engages in $1,300 worth of other goods consumption. Thus, if there was no tax imposed on the worker, we know the worker would in fact be able to earn $1,300 by working for 40 hours a week. Notice that that argument does not require us to believe that the worker would in fact choose the lowercase a bundle if he faced the magenta budget constraint. We're just using the lowercase a bundle to identify how much of a paycheck the worker would be bringing home if he worked for 40 hours a week in the absence of a tax. If working for 40 hours a week results in a paycheck of $1,300 in the absence of a tax and a paycheck of $800 with the tax, then we can conclude that the tax that the worker pays at bundle A is in fact the difference between those two amounts, $1,300 minus $800, or $500 in the tax payment. We will therefore always be able to identify the tax payment that the worker makes by first identifying the actual bundle he consumes under the tax, and then drawing the vertical distance up to the without tax budget constraint. This is a trick that we'll be using repeatedly. Note again that this trick makes no assumption about what this worker would actually do if there was no tax. We're simply using the lowercase a bundle as a tool to help us identify the tax payment the worker does make if he in fact chooses bundle A on the blue budget constraint under the tax.